Alright, the triangle midsegment theorem states that if you know that you have two midpoints on a triangle and you connect them, then that line segment is going to be exactly 1/2 of the parallel side. And here's the theorem that you can record. If a segment joins the midpoints of two sides of a triangle, then the segment is parallel to the third side and half its length. What's another way that I could say that AB equals 1/2 of CD? That's right, we could just multiply by 2 to both sides, and it would be fair to say that twice AB is going to equal CD. And that's how we want to set up an equation if we know a relationship between those two sides. So if you were given that AB is x plus 4 and CD is 3x minus 1, then we have enough information to solve for x and to find our missing sides. Let's try that one out. So I can do double AB, so 2 times x plus 4, I'm going to use distributive property, equals 3x minus 1. So it's just algebra, distribute, and we get 2x plus 8 equals 3x minus 1. Subtract the x's to get them on the same side, so minus 2x. And that gives us x minus 1 equals 8. Add 1, and x is going to be 9. So what would side AB be? Well, 9 plus 4 gives us 13. Plug in a 9 here, and then 3 times 9 gives us 27 minus 1, which is 26. And notice that 13 is 1/2 of 26. So it works. Alright, another connection I'd like for you to make. If we know that those midpoints are there, then we also know that these are parallel. And we also know that this makes two similar triangles. The triangle EAB is going to be similar to triangle ECD. Therefore, we could use a proportion as well to find missing side lengths if we know that they're similar. And we also know the angles are the same. So if you found this angle, then you know it would be the same as this angle. If you found this angle, you know it would be the same as this angle. And then here they both share this third angle, so that's the reflexive property of congruence. Alright, let's try an example question. Given C and D are midpoints of AW and line segment AX respectively, and angle X is 62 degrees, angle A is 56 degrees, find the measure of angle ACD. Alright, let's talk about the reasoning behind this one. First thing, let's fill in what we know. According to the triangle midsegment theorem, I know that CD is parallel to WX. It's given that A is 56, and it's given that X is 62 degrees. CD is actually a transversal to line AX. Correction, that is AX is actually the transversal. So AX cuts through two parallel lines, meaning CD and WX. So that's our transversal. And that transversal, if we extended this out, you can see it a little bit better. How are 62 and this angle right here, angle ACD related, ADC related? They are corresponding. So according to corresponding angles, I know that they are going to be congruent. So I'm going to label that one 62 as well. And now we know angle A is congruent to angle A. Why is that? The reflexive property of congruence. And that helps us because it proves that angle A for the large triangle is congruent to angle ACD for the small triangle. And then when we have a theorem that says if two angles of two triangles are congruent, then we know the third angles are going to be congruent. And we know the triangle sum theorem states that it's 180 degrees in the triangle. So let's look at our small triangle. So triangle ACD. We know two of the angles, so if we add them up, 56 and 62, we get 118 degrees. If we subtract that from 180, according to the triangle sum theorem that states that it's 180 degrees for a triangle, then we know it would be 62 degrees. So our missing side is 62, and we just stated if you know two angles of triangle are congruent, then you know the third one is. What's another way you could prove that? AW is the what of CD and WX? That's right, it's the transversal. It's a line that cuts through two parallel lines. So 62 and this are going to be corresponding, so angle ACD is corresponding to angle AWX, so we know they're congruent. So we just found all of the angles on this triangle, and we could actually go a step further and say supplementary we could find in these, but those aren't actually part of the triangle. So we found ACD, and we even found AWX while we were at it. Alright, example 2, find X and Y. Look carefully at this. You have a bunch of hash marks here. So since these each have equal number of hash marks, we know that this point is the midpoint. Same thing here. These both have equal number of hash marks, so that point's the midpoint. And here they both have equal hash marks, so this is our midpoint. So we know this side's half of this side, or vice versa. This is double this side. We know that this side is double this side, and we know that this side is double this side. So a bunch of connections we can make right away. Alright, I'm looking at the y and the x, and I'm not liking two variables, so I'm not going to try that one first. I'm going to try the ones that have the same variables first so I can solve for x. Once I know what x is, I can plug it in here. That way I'll only have one variable. So if I double this side, it's going to equal this side. And setting it up, it looks like this. 2 times the x gives us 3x minus 4. Now let's just solve for x. We get negative x equals negative 4, so that means positive x equals positive 4. So we solve for x. We're halfway done. Now let's take that x value and plug it in to our 2x minus 1. So that would be 2 times 4 minus 1, which gives us 7. So this whole side length is 7, I know. Well, that's pretty helpful. We know that this is double this side, or we could say y is half of 7. So we could set it up like 2y equals 7, divide by 2, and we're talking about 7 halves, or 3.5. There we go, we found both of our variables. Now you're ready to try some on your own.